All right, so in the last class, we talked about how to prove congruent triangles using the postulates SSS and SAS. So side, 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 and side, angle, side. Today we're going to learn two additional postulates that you can use to prove triangles are congruent. This first one we're going to talk about is the ASA postulate. So it states if two angles and the side between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. All right, so for example, you see here we have angle B and angle C, and the side that they share, that those two angles share, is line BC. So that would be angle, side, angle. Okay, same with over here. You wouldn't have angle, um, an angle and, or an angle, a side and a side, or an angle and a side over here. Okay, the side has to be in between the angles. All right, and then our second theorem or postulate that we are going to talk about today is the angle side theorem. Okay, so if two angles and a side not between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. Okay, so in this case, the side does not have to be between the two angles, but it does have to be connected to the other angles. So for instance, we have angle G, angle F, and side FH, and they correspond to the angles and the sides in triangle KJI. All right, so we can use these two postulates and theorems to use to do some proofs. So we're going to do a proof real quick. So we're given that AE is congruent to CB, and we have that AB is congruent to CD. All right, and then we have that B is the midpoint of ED. Okay. All right, so they give us our statements here. We just have to come up with the reasons for these statements. So the first set, I'm sure you've already figured out, are my givens. All right, now it states that EB is congruent to DB. All right, and the reason for that, if you haven't figured it out, is because we can get this from this step right here. And so we can just say it's from the definition of a midpoint. All right, now this particular proof does not have to do with the two postulates that we learned in this particular video, but the one we learned in the last one. And so if you look at our triangles, we can clearly see that these two triangles are congruent by side, side, side. All right. All right, so we're going to keep going, do a couple more proofs, just so you guys get the hang of seeing these. Okay, so we're given that AB is perpendicular to BE, and that DE is perpendicular to BE. Okay, we also have the AC is congruent to DC, and then we have the angle BAC is congruent to EDC. All right, and we're trying to prove that these two triangles right here are congruent to each other. So the first two reasons on here we can say are our givens. All right, and then it says that angle B and angle E are right angles. All right, now we get this particular statement from this one up here, and I'm sure you've already figured out the reason for this is because all perpendicular lines create right angles. So we could actually say it's the definition of a perpendicular line, okay? Now we can also say that angle B is congruent to angle E, okay? And the reason for that is because they are both right angles, they are obviously congruent. So we could say um, right angles are congruent, okay? Now, if you look at my triangle up here, we can actually safely say that these two triangles are congruent by the oops, the angle side theorem, angle side. All right. One more proof for you. I am going to let you try and do this one on your own. I'm not going to give you any of the statements or any of the reasons, but I do want to see this in your WISC tomorrow. So we have the given, which is SQ bisects the angle PSR. We're also given that angle P and angle R are congruent, and we need to prove that these two triangles are congruent to each other. All right, so I want you to go through, write yourself a 2-column proof about this, and I will check it over tomorrow. Otherwise, this is all I have for you on about these two postulates today.